Students, welcome back to today's class on playing with numbers. Playing with numbers, the name itself says that we are going to play with numbers and it's a very interesting topic. Let's start today's session. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start the class. So what are we going to discuss in this chapter? It's all about numbers. And what I mean by playing, okay, let us try to say that a number is given, for example 556, but I don't know whether that number is divisible by 4 or not, divisible by 3 or not, divisible by 5 or not, right? So how to see when the number is given, how to find whether it is divisible by some number or not. So without the actual divisions, that we are going to discuss in today's class. Okay, so let us try to take one small situation. Ravi and Raj, there are two friends, Ravi and Raj. Okay, so Ravi said to Raj, think of a number. Okay, let me think of a number. Okay, so let us say a number 57 or 52. Let me say the number is 52. Think of a number, reverse the number. Reverse means just till these numbers. Okay, it can be any digit number, don't worry. Okay, here I'm taking a 2-digit number. Add both of them. Okay, 5 plus 2 7 and 5 plus 2 7. Good. Okay, let's see what result can we get. And Ravi is saying, I'm sure there is no remainder when the sum is divided with 11. There is no remainder. What do you mean by no remainder? That means the remainder should be 0. Remainder should be 0. 11 and 77. If you divide with 11, 11 sevens are 77. And yes, the remainder is 0. Right? When the sum is divided with 11. But the thing is, how come he know my number is 77? Okay, let me try with another number. Okay, let me take 34. Okay, or 32. And another number 23. So 3, 4, 5, 3 plus 4, 2, 5. 55, yes, it is also divisible by 55 is also divisible by 11. Okay, so how could he say without knowing this number that this number is divisible by 11? That means there is some logic behind this one. There is some rule behind this one, right? So such type of rules exist for many other numbers. So all those we're going to learn today. Okay, so the first one, we're going to learn about expanded form of a number, okay, which you already know, which you have already discussed earlier, okay, in the lower classes. But once again, let us try to discuss about expanded form just in 1 or 2 minutes. And then we're going to discuss about divisibility rules in this class. And after that, we're going to discuss about factors and multiples. Even factors and multiples, you are aware of that, but let us try to have a small recap of all those, right? The first one we're going to see, let us try to see what is a place value. Okay, when we are discussing about expanded form, what do you mean by expanded form? Let me tell you that. Okay, for example, you want to expand the number 7369. What are place values, do you remember? Place value is a units place, that means a 1. Tens place, hundreds place, thousands. If more numbers are there, 10,000s place, 1 lakhs, 10 lakhs, 10 crores. Okay, so all these are the place values. Now, what is expanded form of this number 7369? 7369, see, this units place, okay, ones place, units or ones place, 7369, okay. The number after that will go for tens place, the number after that will go for hundreds, and the number before that will go for thousands. Always you should come from the right to the left. Don't go from this number, ones, tens, hundreds, no, that should come from the other side. Okay, so once 9 into 1 will give you 9. That means the value of 9 is 9. But for 6 into 10 will give you 60. The place value of 6 is 60. In the same way, hundreds, 3 into 100 is 300. Right? And 7 into 1000 7 into 1000 is 7000. 7369. Those are the place values, and that is how we write expanded form. Okay. Let's move ahead. Write the following numbers in expanded form. Very easy. Okay, you already know that. One example is also given. 25,984. 25,984, and we also know how to use commas, correct? 25,984. So 4 is in ones place, okay. The next 8 is in tens place, 80. 9 in hundreds, 900. 5 in thousands, 5,000s, and 20 in 10,000s. I mean 2 in 10,000s, that becomes a 20,000. 20,000. 20,000 plus 5,000 plus 900 plus 80 plus 4 will give you 25,984. 25,984. In the same way, the next one, 95,843. 95,000. So come from last. 3 into 1 is 3. Okay, that is the same 3. Next, for 4 it is 40. Okay, 40. Next, 8 is in hundreds place, 800. Plus the next number is 5, which is again in thousands place, 5,000. And 9 is 90,000. It is in tens place and it is in 90,000. Okay, 90,000, 5,843. Correct? In the same way, you can write these two. Okay, you already know how to write this one. We have already discussed that in the previous classes. Okay, so let's move forward. Let's try to take the first divisibility rule. Okay, divisibility rule. What do you mean by divisibility rule? I told you, if you take a number 56, how can you check whether that number is divisible by 4 or not, 3 or not? So there should be some logic behind that without the actual division. So that is called divisibility rule. The process of checking or verifying whether the number is divisible by a given number or not without the actual division is called divisibility rule for that number. It's called the divisibility rule. Okay, let's try to have a small discussion. For example, 10 is there. Do you know whether 10 is divisible by 10 or not? Yes. 20? Yes. This is 10 into 2. 500, 10 into 50. Yes, it is divisible. 80, 8 into 10 or 10 into 8. 8690, 10 into 869. So all these numbers are divisible by 10. How can I say that? What logic is there? What logic is there hidden inside that as soon as I see the number, I can say that it is divisible by 10 or not? Okay, you can see here, every number ending with 0. This is very important. All these numbers are ending with 0. Carefully observe. All these numbers are ending with 0. Every number ending with 0 is divisible by 10. Every number ending with 0 is divisible by 10. 234, is it divisible by 10? No. Why? It is not divisible because there is no 0 at the end. But what about this number 23402? Although we have a 0, but we don't have at the end, at the units digit. We need to have 10 at the units. The number should be ended. The number should end with 0 at the units place. Okay. So now what about this one? Yes, this complete number is divisible by 10. Okay. For 10 it's very simple. But let us also try to see the other divisibility rules. The next one we are going to discuss, the very first one in this sequence, that is divisibility by 2. Divisibility by 2, you know that 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, so on. So many numbers are there, so many numbers, right? So I'll take some arbitrary number 1,01,453 and I ask you, is it divisible by 2? And you should not sit and divide everything. We need to have a small logic behind that. So what is that? You can see a number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. What do you mean by ones place? Units place. In that ones place, if you have any of these numbers 0, 2, 4, 6, 8, we can say that number is directly divisible by 2 without any other thought. Okay, you can see here 126 is there and the number in ones place is 6. So now tell me, is 6 divisible by 2? Yes, because 0, 2, 4, 6, 8. The ending digit is 6. Yes, it is divisible. That's it. For the number 2, I can even I can say that more easily, all these are even numbers. All these are even numbers, correct? A number is divisible by 2 if and only if it is an even number. So just by seeing the number, even or odd, even means it is divisible, odd means no. Even 100%, odd 0%, true or false, even is true all the ways. Okay, 332, 2 is there even number in one's place, it's 2. Also you can say that it is an even number, and if it is even number, it is divisible by 2. 487, 7 is not an even number, and so it is not divisible by 2. 128, yes, 8 is an even number, 8 is in one's place, right? 569, no, it is an odd number, it is not divisible by 2. If you want to verify, you can take any number. Okay, don't have to take big numbers, you can also start with small numbers. You can see 12, 14, 16, 18, 20, all these numbers are divisible by 2. But all the odd numbers, 11, 13, 15, 17, 19, so all these numbers are not divisible. All these numbers are not divisible. Understand? Let's move ahead. Let's go for the next one. Divisibility by 3. Just now we discussed about divisible by 2. And what is the logic behind that? Divisibility by 2 means every even number is divisible by 2. Or the ending digits should be 0, 2, 4, 6, 8. The same way, there is some logic for 3. What is that? Let's try to see here. A number is divisible by 3. We are discussing about 3. If sum of the digits, what do you mean by sum? For example, I'll give you 123. Sum of the digits means add all the digits. 1 plus 2 plus 3, 3, 4, 5, 6. 6. 1 plus 2 plus 3. Is it divisible by 3? Yes. If sum of the digits is divisible by 3. Is divisible by 3. Okay. So 123 as the sum is 6, which is divisible by 3. Yes, we can say that 123 is divisible by 3. Let's try to take small examples. 126. How much is that? 6, 7, 8, 9. Just add the numbers. 9, 10, 11, 12, 13, 14, 15. Okay. 8, 9, 10, 14. Okay. 5 plus 4 is 9. 9 plus 0 is 9. 5 plus 6 is 11. 11 plus 9 is 20. Is that correct? So these are the digits. So now the point is 9 divisible by 2? It's not divisible by 2. We are talking about divisibility by 3. We are talking about divisibility by 3. Okay. Sum of the digits is 9. Is it divisible by 3? Yes. 9 is divisible by 3. So I can say that total 126 is divisible by 3. 15. Yes, it is divisible. 3 into 5. 14. No. 14 is no. 9. What about the 9? 9 is divisible. Again, it is divisible by 3. So the complete number 540 is divisible by 3. 20 is not divisible by 3. So this is how you can understand whether a given number is divisible by 3 or not. Divisibility by 2, even number, done. Divisibility by 3, sum of the digits should be a multiple of 3 or should be divided by 3, should be divisible by 3. Okay, next one. A number is divisible by 6. A number is divisible by 6. Now, when I discuss about 6, I know 6 can be written as 2 into 3. Right? Those two are prime factors, prime numbers 2 and 3 are. So I can say that if a number is divided by both 2 and 3, it will be definitely divisible by 6. So the only logic for 6 is it should be divisible by 2 and 3, and we know that for 2 it is an even number, for 3 the sum of the digits should be divisible by 3 again. Okay, so a number is divisible by 6 if a number is divisible by both 2 and 3. By both 2 and 3, correct? So let's move ahead. 504. 504, is it divisible by 2? Yes, why? Because 4 is an even number. Good. 9? No. 6? Yes. 9 again? No. But now what about divisible by 3? So we need to add the digits. 5 plus 4, 9. Yes, it is divisible by 3. 3 plus 3, 6. 6 plus 9, 15. Yes, it is divisible by 3. 2 plus 8, 10. 10 plus 6, 16. It is not divisible by 3. And 5, 69. 6 plus 5, 11. 11 plus 9 is 20. And this is also not divisible by 3. So the point here is 504, when we are taking by 2 and 3, as both the numbers are true, it is divisible by 2 as well as 3. It is completely divisible by 6. It is completely divisible by 6. Okay. What about divisible by 2 and 3? 2 and 3 divisible by 3. Okay. So as it is not divisible by 2, we can straightforwardly say that it is not divisible by 6. In the same way here, 286, it is true for 2 but not for 3. So still it is not divisible by 6. And here both the things are false, and you can say that it is not divisible by 6. It should be divisible by both 2 and 3. 2 and 3, and means both of them. It's not just 2 or 3. In some cases, if you find 2 or 3, or means any one can happen. And means both of them should come. Both of them. I or Ravi and Raju are going to market. Ravi and Raju means both are going. Ravi or Raju, that means any one person is enough to go to market. Okay, right. So the next one, every even number divisible by 3 is divisible by 6. So if there is an even number, definitely we can say that it is divisible by 2 already, and again divisible by 3. So the total count can be divided by 3, by 6. Right. We started with 2, we started with 3. 2 into 3, we started with 6. Okay, so let's move ahead to know the next divisibility rule. Okay, we have a small question here. What is that? Which of the following numbers are divisible by 2, 3 and 6? By 2, 3 and 6. Let us try to take the number 3217. Again, the same type of process. I'm not going to do it completely. Okay, I'm leaving that for you. I'll just try to discuss one or two. 3217. Is it an even number? No. It is enough. I will not check that. It is not divisible by 6. But for 3, what we do? We just add these two. 3 plus 2, 5. 5 plus 1, 6. 6 plus 7, 13. 13 is not divisible by 3. 4, 3, 3, 5, 0, 4, 5, 6, 7, 8, 9, 10. 10 plus 5, 15. 15. Sum of the digits is 15. Yes, it is divisible by 3. And here, the last digit is 0. Yes, it is an even number. As these two are true, it is divisible by 6. The same way you can proceed with the remaining things. Right. So let's move ahead for the next one. Write the smallest digit and the greatest possible digit. Understand? Try to understand properly. Write the smallest and the greatest possible digit in the blank space of each of the following numbers so that the numbers formed are divisible by 3. Divisible by 3 means sum of the digits should be 3. Sum of the digits should be multiple of 3. Okay. First of all, let us try to add all this. 6 plus 7 is 13. 13 plus 2, 15. 15 plus 4, 19. Once again. 6 plus 7, 13. 13 plus 15. 15 plus 4 is 19. Okay. Now for 19, what is the nearest number that you can add so that the number is a multiple of 3? 19, no. 20, no. 21. 21 is a multiple. So 19 plus 2 will give you 21. 19 plus 2 will give you 21. So I'll keep 2 here. So I'll write a new number. 26724. 26724. It is a number divisible by 3. It is a number divisible by 3. You can carefully check that. 6 plus 2, 8. 8 plus 1, 15. 15 plus 2, 17. 17 plus 4, 21. 21 is exactly divisible by 3. Okay. So this is the least number or the smallest number. Why this is smallest? Because we just took the nearest number 2. Let's move ahead and go with the more digits. 19 plus 9, 19 plus 9, 28. Is it divisible by 3? No. 19 plus 8, it is 27. Is it divisible by 3? Yes. So the other number we can keep it here is 8. Okay. So that number will give you 8, 6, 7, 2, 4. So 8 plus 6 is 14. 14 plus 7 is 21. 21 plus 2. 21 plus 2 is 23. 23 plus 4. 27. The sum of the digits is 27. Yes, it is divisible. And this is the greatest, or you can say the highest number, which is divisible by 3. In the same way, you can try to find these two. 4, 7, 6, 5, some number with 2. Just add the numbers. 4 plus 7, 11. 11 plus 6, 17. 17 plus 5, 22. 22 plus 2 is 24. Once again. 11. 11 plus 6, 17. 17 plus 5, 22. 22 plus 24. Yes, it is exactly divisible. It is exactly divisible by 3. So, the least number you can go is with 0. The least number you can go is directly with 0. You can keep 0 here. You can see 476502. 476502. Yes, it is. The least number that can be framed here such that it is divisible by 3. In the same way, you can find the greatest, and you also please try to do that. A very simple approach. A very, very simple approach. Okay. No complications are here. Let's move ahead. Let's try to understand about divisibility by 9. We discussed divisible by 2, by 3, and we also discussed by 6. Okay. Now, let us try to understand the divisibility by 9. 9, again, the same thing like 3. The sum of the digits should be a multiple of 9. The sum of the digits, a number is divisible by 9 if the sum of the digits is divisible by 9. Is divisible by 9. Okay. Let's take few numbers. 504 again. 5 plus 4 is 9. So now tell me, is 9 divisible by 9? Yes. 72954. Well, let us try to add. 7 plus 2, 9. 9 plus 9 is 18. 18 plus 5, 23. 23 plus 4, 27. Once again. 5 plus 4, 9. 9 plus 9, 18. 18 plus 2, 21. 21 plus 7, 28. So now tell me, 28 is it? It's not 28, I'm sorry. 5, 4, 9. 9 plus 9, 18. 18, 20, 27. Okay. 27. Is it divisible by 9? Yes. 186. 6 plus 8, 14. 14 plus 1 is 15. Is it divisible by 9? No. So, 186 is also not divisible by 9. 369. 6 plus 3, 9. 9 plus 9, 18. 6 plus 3, 9. 9 plus 9, 18. Okay. 18 is again divisible by 9. Yes, that is correct. Are you understanding how to do all this? Just add the numbers and see if it is divisible by 9, yes or no. Okay, so let's move ahead. Let's try to understand about divisible by 5, and with this we'll stop it here. Okay, numbers with 0 or 5, numbers with 0 or 5 at one's place, 0 or 5 at one's place are divisible by 5. You can see the table 5. 5 into 1 is 5. 5 to the 10, 15, 20, 25, 30, 35. All these numbers either end with 0 or 5. Okay. 5 is the multiple 10, 15, 20, 25, 30. So, all these numbers either end with 0 or end with 5. So, the unit digit should be either 0 or 5. Okay. So, let's try to take unit digit is 5. Number in one's place, yes. 0, okay, yes, that's correct. 9, no, so it is no, it cannot. 5 again, yes, it is divisible by 5. Number in one's place is 5. Here it is 9. Right? So are you understanding how to see whether a number is divisible by 2, by 3, by 5, by 6 and by 9. So furthermore, going towards in the next class, we're going to discuss about divisible by 10. And after that 10 also we have more applications like divisibility by 4, divisible by 8, divisible by 11 and so many other things which we are going to discuss in the next lecture. Right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.